Hello, welcome for our science lesson. In the previous lessons we were looking at the Earth in space, and at this time we are going to focus on seasons and eclipses. On the prehistoric human, the human being observed the period and the changes in seasons, and they tried to do so by finding ways to mark the passages of time and various events. For instance, in Egypt, River Nile flooded once a year. That one, it could bring the fertile soil. So it was very important to prepare them to know it is time to plant some various crops. And during that time, it could be able to assist them to determine the types of crops that were able to be planted. And therefore, when we look into the seasons, we'll be able to find out one of the effects of the revolution of the sun, of the earth, around the sun, scientifically is the one that leads to the causes of seasons. But previously, before we come to this is a scientific way. Before we come to understand on the scientific means of determining the seasons, in the prehistoric time, human beings were able to observe only events that were occurring at some certain period of time, and these events were very much important to help them identify the time and the seasons they are living in. I've just given an example of River Nile. That one is in Egypt. Once it used to flood every year. And as a result of that, the flooding produced what we call silt. Silt is a fine deposition of River Nile, and along the River Nile, people could be able to practice what we call crop farming. Therefore, it was intertwined with the crop farming. Flooding was intertwined with crop farming, and therefore it was enabled time and important for them to know when is this time to occur and when they are going to be able to plant some crops. Therefore, what is a season? A season is a division of the year that is marked by changes in weather. It can also be ecology. It can also be the amount of daylight. Remember, in the previous lessons, we were able to look at the effect of the rotation of the earth. It was creating day and night. I hope so. It could also lead to the deflection of ocean currents and winds. It will also be causing the time differences between the longitudes. Therefore, when we look at those effects of the rotation and combining them with the revolution of the earth around the sun, we are going scientifically to mark up the events of the seasons and changes. We'll be able to focus on weather, ecology, and the amount of daylight that is produced in the course of the day. And seasons are caused by the Earth's orbit around the sun. This is a representation of the Earth orbiting the sun, following a special path that is known as the orbit. In the process of the Earth orbiting the sun, there are different seasons that are produced. These seasons are caused by the Earth's axial tilt in relation or relatively to the elliptical plane of the Earth. When we go in the polar regions and the temperate regions, the seasons are marked by changes in the intensity of sunlight that reaches the Earth. This sunlight, whenever it reaches the Earth's surface, it has got some form of variation. from which it may also cause the animals, either animals and plants, to hibernate, or it may lead to the plants getting extinct or flourish. One way of monitoring the seasons was to observe the phases of the moon in the ancient Egypt and the olden days. From the Egyptian, they had the calendar of 12 months. The Egyptians had a calendar of 12 months. Each was having a 3 10-days week. A 3 10-days week, and the months were named according to their gods, the gods of the Egyptians. They had different gods. Therefore, they added 5 festive days at the beginning of the year, which could lead to the formation of their calendar. That means they had 12 months, and each month had 10 days of festives that was categorized into 3, and then had a 10 days festive, and then we add 5 days which were at the beginning of every year. There are 5 days of fasting in Egyptian calendar. You could be able to determine these add up to around 365 days. This is a complete 1 year. That is how the Egyptians could be able to determine their seasons, and they had various seasons that were culminated in 12 months, and each was having what we call 10 days of festives, and every year there were 5 days of festives. And therefore, when you do your arithmetic, you multiply 12 by 3, and by 10 you will get 360. When you add 5 days, you will be able to get what we call 365 days. That is equivalent to 1 year. Then let's move to the Australian government, or Australian. How do Australians determine their seasons during their ancient days? You will find out for yourself. The reasons for bringing out these seasons, when we determine on this. In the ordinary year, we actually have scientifically, we have 365.24 days in an ordinary year. That is the scientific method of determining the number of days, which is equivalent to actually 365.25 days. This is for the ordinary year. And then a leap year has got 366 days. This means scientifically all these seasons have been determined to move in a period of 3 months. From season 1 to this, there are a period of 3 months here for this summer season to change into autumn seasons. And therefore, we also have a period of 3 months here for the autumn season to change into winter. And eventually the winter seasons will change. We'll have a change period of 3 months into the spring seasons, which will lead eventually into the summer again. 360. We have 366 days. This is during the leap year. We have the leap year. And then we have 365 days. Scientifically 2.4 days. This is for the ordinary year. Then when you calculate, especially during these seasons, they are normally affected by the leap years. And the leap year means there is 366 days, while the ordinary year have got 365 65.24 days. As a result of that, we are able to determine the number of days that the earth will take to revolve around the sun from season 1 up to the 4 seasons. Remember, we have the summers, autumn, winter, and spring. We can be able to calculate. For example, in Europe, during winter comes to around the 4th, winter comes to be a period of the 3rd period or season of the year. When it is in Europe, in Africa, they will be having what you call the summer. Therefore, if you are in Africa, you determine the number of days that the winter will be experienced in Europe and at the same time will be experienced in Africa. Therefore, you calculate using the leap year, and for that case, we have been able to look at it. Winter is in the season 3 of the 4 seasons. I had said you take 3 out of 4 multiplied by 366. 366 days. If you do the division, and then you'll get 91.5 days multiplied by 3, you will get around 274.5 days. Sometime they may also ask you about the summer or even the autumn or even the spring. The same applies to our knowledge and our understanding. This is about the scientific means of acquiring the seasons. But remember, I want to illustrate something very important here, because these seasons, when the earth is revolving around the sun following the orbit, there are some specific actions that normally happens. The earth has got what we call the longitudes and the latitudes. That one will help us also to determine the time differences. That one will help us to determine the time differences in the period as we move on. This is a representation of the earth. Remember, this is the equator, which is at 0 degrees. And then this is the GMT, the Greenwich meridian, which is longitude 0 degrees. And then it is also having some various longitudes that will give us different places of time. And in the course of the time, you'll be able to realize that we also have some regions on Earth. Like this one is the Arctic Circle, which is 66.5 degrees north. This is almost 23.5 degrees north. And then this is 0 degrees. This is 23.5 degrees south. And then this one is Antarctic Circle, 66.5 degrees south. Therefore, these latitudes also help us to determine the places and their seasons. At the same time, when we look at the various longitudes, the Earth as a globe is divided into 360 degrees longitudes. There are 180 longitudes on the eastern sides and also 180 longitude lines of longitudes on the western sides. Remember, one of the effects of the revolution of the earth and rotation, it calls the time difference. Time difference between the meridian. And this is what I would like us to address shortly before we move on the seasons and look at the eclipses as we wind up. The time difference is able to help us. This is longitude 0. This can be point A, this can be point B. Remember, these are different places on Earth's surface, and they have what we call the time difference in the manner of the revolution. As the Earth inclined to the sun's rays, you'll be able to find that there is a cause of time differences. And these time differences will help us to be able to understand. For instance, suppose the local time at GMT. Suppose the local time at GMT is noon. And noon means there are 12, this is 12 hours. What is the local time at station X? Which is at longitude 40 degrees east. This can be point A. For the purpose of time reference and calculations, we'll be able to understand that. We'll have first of all to get the time difference here. What's the difference here? We'll have to get difference in degrees. At GMT, the angle is actually the time, or the degrees, it's at 0 degrees. Therefore, you'll get 0 degrees, subtract 40 degrees, you'll get 40 degrees. And then we get 40, we change into minutes. Actually, the Earth takes in 1 hour, it takes around 4 minutes to cross 1 degree. You multiply it by 4, you will get 160. You'll get 160 degrees. And then these 160, you convert them. You'll have that 60 degrees is equivalent to 1 hour. We change them into hours. Therefore, you divide by 60 minutes. That is 60 minutes. And then we are going to get around 2 hours and 40 minutes. Therefore, they have been asking the time at station X. The time at station X will be, it is 40 degrees east. It is ahead of the Greenwich meridian, or the GMT time, because at that time it will be noon. Therefore, we'll have a time difference. Therefore, we'll take 2 hours 40 minutes. We'll add to 12 hours. What are we going to get? It will be 1440 hours. That is the time at station X. This is important because it helps even the people who are flying in different regions to know actually the time and the distance they are going to cover. Therefore, this is one of the way of finding out the time difference of some time of using the longitudes. What about if you are given the longitude of a place, and they are asking you, maybe they have given you 2 times, and you are being asked about the longitude? What do you do? For example, let us look at this question. What is the longitude of a place? That is, what is a longitude? The longitude of a place, this place can be Y, whose local time is 8 a.m. whose local time is 8 a.m. when the GMT time is, or the Greenwich Meridian time is noon. That one is at actually 0 degrees on longitude, 0 degrees. What we are required to do here, you find the longitude. What is the longitude of a place Y whose local time is noon at longitude 0? It is very simple. We have to determine the time difference here. You take 12 hours, that is what it means by noon. You subtract 8, that is 8 hours, that is in AM. What you get, you'll get 4 hours. Now, there's a difference between a place of Y and GMT. The difference in time is, it takes 4 hours. It's the same as point A and point B. This is point A, it is at noon. And then point Y is, we have not been told time. Okay, the time is 8 a.m. Therefore, we are being asked, what is the time difference? What is the longitude? After getting this one, we'll have to take 4 hours. You multiply it by the 60 minutes. You will get around 240 degrees. And when we come to divide them by 60 minutes, you take 240, you divide by 60 minutes, you are converting them all into degrees. Therefore, you will get not 60, we divide them by 40, because by 4, it takes 4 minutes to go through 1 degree. By 4, then you will get, it becomes, that is when it is 60 degrees. But we do not know whether it is east or west. Let us go back to the question. The local time is 8 a.m. when the GMT time is noon. That means from the GMT time it is noon, and then it should be on the west side, on the western side of the GMT. That means our longitude will be 60 degrees west. We have been able to determine the time difference in terms of longitudes, and we are able to tell we are able to find out the difference in longitude. Let us move on and look at various reasons that causes the season. We have been able to look at one. One of the reasons that brings out the seasons is that the seasons results from the changes in temperature. That is, changes in temperature. The changes in temperature result as a result of direct sunlight. The results of direct sunlight on Earth. And that one we have been able to see, this one determines the amount of solar radiation. The amount of solar radiation is the one that determines the temperature as a result of the direct sunlight. That is the one that will bring out variations in seasons on Earth. When we consider the celestial motions, which we have been able to see that it takes around 365.24 days to go through the orbital or elliptical movement of the Earth around the Sun. It is the one that brings variation of this. For example, when the Earth is at this point, this is the Sun, and then this is the Earth. This is also the Earth. As the Earth is trying to move around the Sun, that is what we call revolution, it produces the season. At the same time, the Earth itself makes what we call the rotation. And a complete rotation takes 24 hours. A complete revolution takes around 365.24 days to make a complete rotation. Therefore, complete revolution. Therefore, we are looking at the revolution as the Earth tries to go around the Earth. It also rotates. Therefore, this part receives sunlight or sun rays. Therefore, the amount of solar radiation will increases, especially when it is within the tropical regions. And that is where we'll have what we call the equinoxes. This is the time of the year when the Earth receives direct amount of solar radiation, having 12 hours of solar radiation and 12 hours of night. Therefore, this is 12 hours of the day and then 12 hours of the night. The equinoxes also will be able to be seen. The Earth will have equal days or equal time during the equinox. And that one will also, another effect will, during the seasons, it will produce what we call the solstices. And a solstice is a period when the Earth receives direct solar radiation within the tropic, either the Tropic of Capricorn, which is 23.5 degrees. This one is north, or the Tropic of Cancer, 23.5 degrees south. When the sun is overhead within these tropics, then we'll have either to experience the solstices. And we have various types of solstices here. The solstices, as they are produced, we have the summer solstice, and these happen in the northern hemisphere. And then we also have the winter solstice. It also happens in the southern hemisphere. For example, when we look at the equinoxes, equinoxes occurs in two different dates. Equinox have two different dates. One is actually on 23rd of March. The month of March, and two, when the sun is overhead again the equator, that is on 23rd, between 23rd and it is always the month of September. This is the time when now the sun is coming back and crossing again the equator towards the southern hemisphere. Therefore, in the southern hemisphere, we will be experiencing what we call the winter solstices, as the sun passes over the Tropic of Cancer on 23rd of March. in the southern hemisphere, they will be experiencing what we call the winter solstice. Whereas in 23rd of September, in the northern hemisphere, they are experiencing what we have the summer solstices. This is the seasons of which we are considering them happening. We also have another dates of the solstices. This is about the equinoxial dates. We also have around the 22nd of June and December. The sun is overhead the Tropic of Capricorn. And that one is in the southern hemisphere. The southern hemisphere will be experiencing what we call the summer solstice because the sun is overhead the Tropic of Capricorn. That means the solar radiation is felt in some parts of the hemisphere in the southern area. And that brings or making the winter solstice in this environment. And we'll find that in the southern hemisphere, there are some around 6 hours of sunshine and then 18 hours of darkness in the northern hemisphere. This is the time when the earth reaches what we call the climax of its equinoxes. The same also appears again on 21st of June. Every year of 21st of June, there is an appearance of what we call 21st of June. 21st of June, there is the summer begins. This is the time when the summer begins, and it happens in the northern hemisphere. It happens in the northern hemisphere. This is the time when the sunshine is experienced throughout a larger places of the southern hemisphere, of the northern hemisphere, and therefore leading to what we call the snowfall, or in the temperate region, we will have what we call the snowfall. And sometime the snowfall is the time when there is very low temperatures. Very low temperatures have been felt. Remember, the changes in temperature as a result of the cause of this amount of solar radiation that is received on Earth's surface brings about the seasons. We've been able to look at all these changes. All these changes are able to work, and they are seen especially when you look at the midday sun along the equator. Will experiences the equinoxes, and they have 2 equinoxial dates. I had already written them down. The equinoxial dates are 23rd of September every year and 23rd of March every year. The solstice dates include 21st of June and 22nd of December. You will find that these are 2 dates when the earth experiences equinoxes. And these are 2 dates when the earth experiences the solstices. Depending, is it either the winter solstice or the summer solstice, and that one can either happen in the northern hemisphere or the southern hemisphere. Maybe for us to be able to look to understand about the hemisphere of the earth, This is now the southern hemisphere, and this is the northern hemisphere. This is 23rd. 23, that is 23.5 degrees. It is found in the north, and this is what we call the Cancer, the Tropic of Cancer. Whereas this one is 23.5 degrees south, is the Tropic of Capricorn. This is the time when the sun is overhead in the Tropic of Capricorn. These regions experiences what we call the winter solstice. This is the time where there is a snowfall because temperatures are very low. Remember, sun's rays are focusing in the Tropic of Capricorn, therefore blocking the northern hemisphere from experiencing what we call amount of solar radiation. Therefore, we'll have here winter, that is the winter solstice. But when the sun rays appears in the northern hemisphere because of the tilting angle, the inclination angle, the southern hemisphere will also experience what we call the winter solstices. Again, the snowfall begin because temperatures are very low. But now, when the temperatures are high in the northern hemisphere, we now refer to this as the summer solstice. And when the temperatures are very high here, we'll also have to experience the summer. Therefore, we have two summer solstices. One happens in the northern hemisphere and another one happens in the southern hemisphere. Whereas also two winter solstices, one happens in the northern hemisphere and another one happens into the into the southern hemisphere. That is what is able to give us in relationship to the amount of the solar radiation in terms of rays. Remember, the equinoxial dates comes when the solar radiation is received on Earth's surface at around the equator, where we'll have 12 hours of days and 12 hours of the day and 12 hours of the night, and bringing the difference in terms of time. Let's look at the last bit. We'll be looking at the eclipses of the moon. The eclipses of the moon. We have the eclipses of the moon. An eclipse is a shadow that is being formulated as a result of either a heavenly body casting a shadow into another heavenly body. For example, we have two types of eclipses here. We'll be looking at the lunar eclipse. And again, we have the solar eclipse. These are still matters in the space. The lunar eclipse occurs when the earth becomes between the sun and the moon, and it will result into what we call the shadow of the earth being casted out into the moon. Therefore, the sun will be the source of light, while the earth is on the straight line where the moon is also. Therefore, when the earth becomes between the sun and the moon, we refer to it as the lunar eclipse. Whereas, when the moon comes between the period when the moon comes between the earth and the sun, we refer to it as the solar eclipse. What happens during the lunar eclipse? What happens during the lunar eclipse? We have been able to learn that the lunar eclipse occurs when the Earth, during the revolution, when the Earth on revolution comes between the sun and the moon. What will be the effect? Making the shadow of the Earth casted into the moon surface. The shadow of the Earth will be casted into the moon surface, and that shadow will produce two types of shadow there: the lighter shadow and the darker shadow. The lighter shadow we refer to as the penumbra, and the darker shadow is referred to as the umbra shadow. I will demonstrate that one using a diagram so that we'll be able to find out what happens during its formation. I will use this object to represent the sun, and then this object to represent the Earth, and then this object to represent the moon. What happens during the revolution of the Earth? Always there are some phases of the Earth that receives sun rays. This is a representation of the sun's rays. When this rays reaches the Earth, you will find that this part of the Earth will receive light, whereas this part of the Earth will not receive light. There will be darkness. And as a result of that, there will be a shadow that will be casted into the moon, because the Earth has blocked the sun's rays from reaching the moon. Therefore, the moon will be able to experience what we call the lunar eclipse. This part of the moon will not have light. It will partial darkness, and this type of darkness that is related here because of this part of darkness is referred to as the penumbra, and then the one that is total darkness found here, it is the umbra, causing the moon to appear like a crescent shape. You will find that now those people, the people who are in the southern hemisphere of the Earth, will see the moon phase to appear in this manner. That means part of the moon has been obscured from receiving direct sun rays, therefore leading into the formation of a phase of the moon. And there are 4 phases of the moon here. One, we will have the crescent shape, we'll have the gibbous shape, and then a quarter, the quarter shape, and the full moon. When these four phases of the moon occurs on Earth's surface, especially during the revolution of the Earth, at a given moment, the lunar eclipse occurs when the Earth becomes between the sun and the moon, blocking the sun rays from reaching the moon, therefore leading into what we call the gibbous phase of the moon. Therefore, this part of the moon is the one that will be able to experience a little bit of sun rays, therefore producing what we call the gibbous phase of the moon. The crescent shape is the type of the phase of the moon that occurs when there is a completely total darkness in the moons. That means the shadow of the Earth has increased into the moon, leading into what we call the crescent shaped moon. Sometimes it looks just like this. Some small portion of the moon are the one that are experiencing sunlight, and therefore the other part has been blocked away from receiving sun rays. Remember, the moon only reflects the light that is received from the sun. The moon does not produce its own light, but it reflects. Therefore, the kind of the reflection that we receive from the moon, that is now onto our eyes, we say there is a particular glowing, some light coming from the moon, although it is a reflected light from the sun. This is how the the lunar eclipse occurs. Let us go on and look at the solar eclipse. We'll also be able to find it out. It's also leading to the formation of some phases of the moon. The solar eclipse. Solar eclipse occurs. A solar eclipse occurs when the moon, as a heavenly body, during its revolution of the earth, comes between the sun and the earth. What happened? Causing or casting the moon shadow into the earth's surface. Therefore, there's some portion of the earth that will experience the shadows coming from the moon. That we refer to is as the solar eclipse. And sometimes it only takes the maximum time has ever been calculated on planet Earth is 5 minutes, because the rotation of the earth takes around 4 minutes to go through 1 degree. Therefore, it has never taken longer time than 5 minutes, depending on either the equinoxial or the solstices that have been formed. Diagrammatically, I will illustrate it using this diagram so that we are able to see the occurrence of the solar eclipse. We will still have a representation of the sun. Therefore, instead of having the earth in between here, we'll have the moon, and then lastly we will have the earth. The earth is relatively bigger than the moon in terms of circumference, and also, therefore, as the sun gives out its source of light, the sun's rays reaches the moon's surface, you will find that this part will experience what we call enormous light. Therefore, most of this light are going to be reflected back. They are going to be reflected back into the space in different direction. That is either on the object that is near the sun or depending on the alignment. But the remaining part, you will find that there is a shadow that will be casted into the earth. This shadow occurs on some particular regions of the earth's surface, creating two types of shadows here. This is the more darkest region, and therefore it will lead into the formation of the darkest, the darkest part of the shadow. We refer to it as the umbra, and then the lightest part is the penumbra. Now, this is Earth. When the part of the Earth receives some shadow that is experienced on Earth's surface, you will find this part of the Earth's surface experience either the total darkness or the partial darkness, depending on the intensity of the blocking of these sun rays, as the ability of the moon to reflect back much of its light into the either other object. It can be a comet or an asteroid, or if there is no object in between the moon and the sun, therefore the sun will be, the light will be reflected back into the space. As a result of that, bringing some shadow into the earth's surface. This shadow, when the shadow occurs on the earth's surface, that shadow, we referred to it as it has occurred at time that is referred to as the solar eclipse or a solar eclipse. And simply it occurs when the sun, when the moon, actually it is the moon, when the moon happens to find itself into the alignment between the sun and the earth, causing various effects on the part of the earth's surface. There are some part of the earth's surface will be able not to see the light, but now they'll be able to experience they will be able to only see, the people on the earth's surface will be seeing some reflected rays of the sun either back and producing what you call a crescent shape moon as a phase of the moon. As I had talked earlier, there are 4 phases of the moon, and sometime the quarter phase is produced in the difference between the solar eclipse and the lunar eclipse, because it happens in partiality. But these are the 2 eclipses that have ever been discovered. Scientifically, we have the solar eclipse and the lunar eclipse. So far, we have been able to look at the various seasons on Earth's surface and how they are produced and their effects. We'll be able to find that human beings are operating in times of seasons, and these seasons have some certain changes on Earth's surface. For example, we are able to look at the variation of the temperature on Earth's surface is the one that causes these seasons. And lastly, we have been looking at these seasons. During the formation of the seasons, there are some certain areas on Earth's surface that receives what we call the lunar eclipse and the solar eclipses. These eclipses are the ones that are responsible to produce 4 phases of the moon, and that is the crescent, the gibbous, the quarter, and the full moon. Those phases of the moon are normally seen in different regions of the world, depending on the apparent position of the Earth in relationship to the direct solar radiation. To coming to that end, we are able to look various momentous seasons and the eclipses of the moon. I hope we shall be able to move on in the next lesson. Have a good day. Thank you.